Alright guys, for some reason, trying to do this the first two times I've tried to redo the second problem, my computer decided to freeze and be weird, so I've since restarted it and hopefully have solved some problems. So, let's try this guy out. First steps first is doing the first derivative. So I have the bottom times the derivative of the top. So 2x minus 2 minus the top times the derivative of the bottom all over the bottom squared, which when I FOIL that guy gives me 2x squared minus 2x minus 4x plus 4 minus x squared plus 2x minus 4 all over x minus 2 squared, which will reduce into x squared minus 4x, over x squared, x minus 2 quantity squared. So here's my first derivative, which I'm going to use him in a little bit. I'm going to take my second derivative. So I have low Sorry, I decided I wanted to not count what I was doing. D high minus high D low all over low squared. Which will be equal to, backtrack. Which when I go ahead and do, we know that because I have a factor of x minus 2 in all of these, I can reduce it down. I can factor it out. So it gives me 2x squared minus 4x plus 8 minus 2x squared plus 8x all over x minus 2 cubed, which when I reduce all of that down gives me 8 over x minus 2 cubed. And again, I will be using that in a little bit. So those are the first two steps. My next step is to find the x-intercept. And that is where your y equals 0. So I'm going to take my original problem. I'm going to seal it in this case so I can see it. I'm going to set that equal to 0. And when I do that, I'm essentially just trying to take the top and set it equal to 0. Now, I try and factor it, and I notice that when I'm multiplying to the last number 4, the only thing that goes into 4 is 1 and 4 and 2 and 2. And no combination of those will add to a negative 2. I get 3, and I get 5, or I get 4, and I get 0. But I do not get a negative 2. So because of this, there's no x-intercept. Next we have the y-intercept, and that's where all my x's are 0. So I have 0 squared minus 2 times 0 plus 4 over 0 minus 2, which is 4 divided by negative 2, which is a negative 2. So that point is 0, negative 2. Next, we have our vertical asymptotes. And those happen where the bottom is 0. So So that's when I have x minus 2 equals 0, whenever I don't want it to be 0. So I'm going to have a vertical asymptote at the line x equals 2. Horizontal asymptotes come next, or my has. That's where I take my problem. Notice how I stole it again, haha. And I divide it up. And I divide by the biggest on the bottom. And since my biggest here is an x, I'm going to divide everything by x. So I have x squared minus 2x plus 4 over x minus 2 over x. Now when I go ahead and do that, I'm left with a factor of x on top. And that would make it go to infinity. And when it goes to infinity, it does not exist. So there is no horizontal asymptote in this case. Next is my domain. And in my domain, it's going to be exactly like what I saw above before. It's going to be my all real numbers except for when x is equal to 2. Next, I have my critical point. And critical points happen where my derivative is equal to 0, my first derivative. So I'm going to go ahead and take this guy. Not the whole thing. There you go. I don't know why it wouldn't give to me. Come on. There you go. It wouldn't scoot down. So that's when I take my first derivative. There he is, and I set it equal to 0. And remember, when you set a fraction equal to 0, it's essentially taking the top and setting it equal to 0. I can factor out an x, so I see x is 0, and I see x is 4. Now, I've already talked about 0 in my y-intercept, so I don't need to talk about it again. What I do need to talk about is what happens when it's 4. So I'm going to plug 4 into my original problem, which is not this guy, but this guy. So I'm going to plug 4 into this. And when I do, I'm going to have a point at 4 comma something. Remember that trick I taught you about storing? Yeah, I'm doing that one. 4 comma 6. So I have a critical point at 4, 6. Next, I'm going to look for my point of inflection. And that is where my second derivative, which was this guy, is equal to 0. And again, since the top would be just, when solving for this, it would just end up being the top equal to 0. Since 8 doesn't equal to 0, it doesn't exist. There is no point of inflection. Next thing we do is we're going to do our chart. So we got to take a look. I'm giving myself some space here. And I'm going to kind of sketch it out for myself. Ooh, that's a not straight line. Let's try that one more time. A little bit better. So here's going to be my chart, which has my, I don't even remember what we called them on our flip chart. And then we've got our first derivative, our second derivative, and my result. And I gotta go see what my smallest x value was. So I've got a 4, I've got a 2, 0. Looks like 0 is my smallest. Because remember, we go mathematically. We go smallest to biggest. So I'm going to see what happens when I'm on the other side of 0. So negative infinity is less than x is less than 0. And then we look at what happens at 0. And I think my next one was 2 and then 4. 2, 9, yep, okay. So then I'm going to look between 0 and 2. I'm going to look at 2. And then I'm going to look between 0 and 4. Going to look at 4. Then I'm also going to look at what happens after 4. Okay, so we know specific things happen at 0, 2, and 4. 0, I was at the point -2, so I'm going to put that on there. 0, -2. At 2, I had a vertical asymptote. And at 4, I was at the point 46. Okay. So I'm going to want to take a look at my first and second derivatives. I'm going to want those guys handy. And since it's not as convenient for me to just look up on my board, I'm going to move my stuff around a little bit so I can see it. So what I'm going to do is I'm going to highlight my whole chart and move it down a little bit. So that way, these guys can be right here for me. So I can see it when plugging in my stuff. I'm going to try and make my chart a little smaller if I can. Group it all up. Make it a little bit smaller. Oof. Yeah, that's what I'm talking about. I just write way too big. It stinks. I wish I could help it, but it's really hard on this thing. Okay. Well, we're going to know that's my first derivative over there. So what we're going to do is I need something smaller than 0. Let's try -1. So in my calculator, I'm going to take my -1 and I'm going to store it. So I'm going to hit -1. My STO button. So see my -1's in there. STO. And then X, which I'm doing this backwards again, and it's not the easiest thing. So it should say STO -1 arrow X. So I'm going to hit enter. So now I see -1. Okay, so I want to plug in -1 into that first derivative. So parentheses. The X button up by the alpha, x squared, minus 4x, close parentheses, division, parenthesis again, x minus 2, close parentheses, squared. So I went ahead and typed in that derivative on my calculator. I can hit enter. And it gives me a positive. So we said positives were increases. So I'm going to write a 9. And then I'm going to go ahead and now do it in the second derivative. So I'm going to hit 8, division, parentheses, x minus 2, parentheses, math 30. Notice how, again, you can see, sorry, it's kind of hard to do this with the light on my camera. Notice again how you can see how I have it in the correct set of parentheses around it. And that gives me a negative, so that's a down. So my first thing, I'm going to be increasing, and I'm going to be down. Okay, now I want to pick a number between 0 and 2. So why not -1? So I'm going to, excuse me, why not +1? I already did -1. So we hit 1, store as x again. Excuse me. Notice how I see 1. And I've already typed in my derivatives. So I'm going to recall that. So I'm going to hit second entry, which I see the storing. That's great. I don't want that though. I'm going to do it again. There's my second derivative. Do it a third time, and hey, there's my first derivative. Cool. I'm going to hit enter. So I get a negative, so I'm decreasing. Then I want to do it again for my second derivative. So I'm going to second entry, second entry, second entry. Hey, there it is. And I get also a negative. So we are down. So I'm decreasing and I'm down. Okay, now I need to do my next interval of between 2 and 4, so why not 3? So I'm going to store 3 in there. Okay, get my fingers going. I'm going to second entry, that's my storing, do it again, that's my second derivative, do it again, there's my first derivative, and whoop, we're negative. So we are decreasing. Do it again, get my second derivative. Whew. I am positive. For a second my 8 looked like a 0 and I was scared. I was like, So here we're decreasing, but we are up. Now, a number between 4 and infinity, let's do 5. So I store 5. We are positive, so we're increasing. And we are positive again, so we are up. So we're increasing and we are up. Ah, I hit a button. Okay, so then next what we're going to do is we're going to go ahead and sketch my graph. And I'm going to fix that a little bit because I'm going to want to be able to draw a little bit more to that side. So nothing really happens until 0. So I have a point at 0, -2. I have a vertical asymptote at x equals 2. Ooh, that's really bad. Let's try that again. I didn't have any I didn't have any horizontal asymptotes. And then I have a point at 4, 6. Okay, so from -infinity to 0, we are increasing, but we are concave down. From 0 to 2, we are decreasing and concave down, so we are an upside down parabola. From 2 to 4, we're decreasing, but we're concave up, which means our y values are getting smaller, but we're still kind of that up parabola like we talked about. And then from 4 on, we are increasing and up. So we have 2 sets of parabolas here on this one. And guess what, guys? We are done. Go do your homework.